do the argument for negative? Why negative?
Because you went the negative way when you started moving.
All right, so let's take a look at that. So as my velocity started out as negative, so my initial velocity is -2 meters per second. My final velocity, since I came to a stop, 0 meters per second. What does that change?
It goes positive.
0 minus -2 is 2. It's a positive change. So if I was moving in the negative direction and I slow down, my acceleration was positive. So we've got some general rules here, some quick and dirty stuff. If you're speeding up, so going faster, the velocity and acceleration are the same sign. So both positive, both negative. So when I started at rest, and then I started moving, well, I went from 0 to some speed, so I sped up. But I sped up in the negative direction, acceleration would be the same sign, negative. As I was moving in the negative direction and slowed down, well, I slowed down, so it would be the opposite sign. My velocity was negative, acceleration would be positive. And if slowing down, velocity and acceleration, that is an S there, opposite signs. There's, of course, a different way of looking at it. Let's just say that you are 14 years old, walking across the gym floor while some seniors are playing basketball. And they want you to get off the court a little bit faster than you were. So you're strolling along like this, and one of the seniors comes up and then pushes you in the direction that you're moving to get you going faster. You sped up. So velocity and acceleration would be the same sign because you sped up. In which direction was the force applied to you? In the direction I was going or opposite the direction I was going?
The direction that you were going.
And it turns out that acceleration will always be the same sign as the net force acting on you. So if you're pushed in the direction you're going, then acceleration would be in that same direction. I should say if the net force is in the direction you're going. So the force, the net force, total force, and acceleration, always same sign. So you can think about it in those terms also, that if I'm moving in the positive direction right now and I slow down, in order to slow down, something has to be pushing back on me. If I got pushed in the direction I was going, I'd speed up. So if I'm going in the positive direction and something pushes against me, and usually friction, then I'm going to slow down. The net force is that way, in the negative direction, acceleration is negative, or I'm traveling in this direction, I'm slowing down, the acceleration has to be opposite. Questions here?
So if the force is negative, like you were saying, the friction is slowing you down
Right,
in this way, then acceleration would be negative too.
correct.
Okay.
If the net force.
Net force.
Yeah, and the reason why I have to throw net in there is I'm pushing on the wall in that direction, but the wall's not accelerating in that direction because there's no force pushing back on the wall. There's probably a stud in there somewhere. Hope. All right, let's take it to the next step. ground. All right, I have a person throwing a ball into the air. Ball's gonna come up, come down, hit the ground. I want to define 4 different times during this run. So at time A, ball just left the hand. Traveling up. At time B, ball is at peak. At time C, ball is in same location as it was at time A, but is traveling in opposite direction. Only one L. And at time D, this is just before ball touches the ground. So the duration of the problem, the ball is just in the air for the duration of the problem. It has already left the hand at the beginning, and it has not hit the ground at the end. In this, so we have, there's a time A, a time B, a time C, and a time D. There's also all the times in between. So there's something happening between A and B, between B and C, between C and D. So when you see the parentheses like that with A and B, this means after A but before B. So the parentheses just means we are not including time A and time B. It's everything in between. If you see a square bracket, if I did something like this, that's from A to B, but you're including A and B. If I did A, B, and then a parenthesis, this is from A to B, including A, but not including B. So this would be between C and times C and D, not including C. This is A to B, including A, time A, and time B. And this one, A to B, including A, but not including B. Or if you'd rather not use not including, you could just say excluding. So what we're going to do is a plus minus 0 exercise. So what I want you to decide is in these 7 time slots, and it could vary from one to another, I want you to tell me when the position is positive, negative, or zero, when the displacement is positive, negative, or zero, when the velocity is positive, negative, or zero, or when the acceleration is positive, negative, or zero. We'll present the answer several different ways. So one way we'll use the brackets and parentheses, another way we'll just put a plus, minus, or zero in the box. All right. I would like you to, 10 minutes of working with the people around you, come up with what you think is the answer, have some good discussion, and then we'll reconvene. And you're placing your bets, do it before we reconvene.
Velocity negative, so it's negative in the X.
So position. Oftentimes it's easiest to go, when is whatever you're looking at, when is it zero? Because unless I've made a mistake, you can't go from plus to minus without going through zero. So if you figure out where zero is, that tells you where the signs might change. Not necessarily going to change, but it might change. All right, so position, when is position zero? The same question would be, when is the ball at the origin?
It's on the ground.
And at what time is it on the ground?
We didn't label that.
That's after the problem. So the position is never zero. So what is it?
Positive all the way.
Yeah. Position is positive all the way because it's above the ground the entire time, and I said up is positive. I could have expressed the exact same thing by writing a bracket A, D, and then NA, NA. So this would indicate the entire time, and then NA just means not applicable. It's never zero, it's never negative. So these are two different ways of expressing the same thing. What you're gonna find on the test, this is the last problem of the first test. I can give you a scenario more complex than this. Have you do the plus minus zero bit. And then I give you 4 different displays and pick one of them. Please don't pick more than one. Or if you're gonna pick more than one, please make sure your answers are the same. So these are just 2 of the ways that you can express the answer. And there's a PowerPoint on Blackboard where I go through an example and I express it this way, that way. I write it out for those who want to write out sentences. And there's another way which I'll eventually show you. All right, displacement. When is displacement zero?
I put never. Displacement.
Never at the starting point?
A and C.
Yeah. A and C. Zero. It is at the starting point at the beginning of the problem. And at C, it's at the same location as it was at A. So between A and C, since those are the zeros, it can only change from plus to minus at those points. So these should all be the same sign, and these should all be the same sign. So from between A and C, is my displacement positive, negative, or zero? Because because as long as I'm above this point right here, I'm on the positive side of my starting point. So it's indeed positive. And from after C, and it does change signs. Where is the velocity zero? B. So if that is the only place, then these are the same sign, and those are all the same sign. All right, before B, velocity is, because you're going up, and I said up is positive, And then after B,
Negative.
for the most part, this far did not cause too much trouble. The last one though, excuse me. At time A, it has left the hand already. I put the person in there, the person seems to confuse the situation. I could have just had a ball starts out moving upwards. The person is just there to give a background story or backstory. The person is irrelevant to this problem. So look at it one way. Is it speeding up, slowing down, or constant velocity in that first region from up to B?
Slowing down. Slowing down.
So if it's slowing down, acceleration and velocity are opposite signs. After B, speeding up, slowing down, or constant velocity?
Constant. At B or after B?
After B.
After B.
Speeding up.
Okay, and if it's speeding up, same sign. So if those are negative, these are negative. But then what happens at B? How is the velocity changing? I know I got a positive velocity here, and it turns to a negative velocity here. So if I'm going from positive to negative, is that a positive change, negative change, or no change? It's a negative change. If I go from any positive number to a negative number, that is a negative change. Negative. The most common wrong answer there is 0. If you recall, acceleration is the change in velocity over the change in time. If acceleration is 0, that means the velocity doesn't change. So if I throw this object in the air, if its velocity is 0 at the peak, and you're saying the acceleration is 0, that means it's going to stay there. It will not move. If the velocity is 0 and doesn't change, the velocity stays 0. But I think we all know from personal experience, it will fall back down. Not 3 on night. What goes up must come down, spinning wheel, watch it go around.
Rings a bell.
Pardon?
It rings a bell.
It'll come to me middle of the night, I'll call every one of you.
Yeah.
All right, so it's negative the entire time. The other way of looking at it, once it has left the hand, let's do the force diagram. What are all the forces acting on the ball after it has left the hand, but before it touches the ground?
Gravity.
I'm gonna nitpick that.
Friction.
No, ignoring air resistance. What's the force? Gravity is a huge topic. We're just looking at one small aspect of it.
The force of his hand.
So,
You're asking what's the force?
once it's in the air, he said gravity, I was nitpicking. I know what you mean, but let's work on the language. What is the force associated with gravity?
Weight.
There we go, or force due to gravity. Yeah, once it's in the air, we have weight acting on it. Which way is the weight acting on it? Weight is acting down, towards the planet. What other forces are acting on it if we're ignoring air resistance? Let's see, weight we got. There's no other, I haven't mentioned anything happening there. There's no rope. No air resistance, so friction goes away. Normal force, is it touching anything?
Yes.
What?
The hand.
The problem is after it. It is not touching the hand in the problem.
So nothing.
Yeah, that's it. Weight is the only force acting on it, and that force is acting down. Acceleration will be in the same direction as the net force, so acceleration is negative the entire time. Now, if I express it with this notation over here, A and C are 0, so I just write A comma C, no brackets or parentheses, it's those points. It is positive between them, so parenthesis A, C, close parenthesis, and then after C, and D is included. Over here, velocity is positive, let's say it's 0 at B. It is positive from A inclusive to D exclusive, and then after B to D. And then acceleration is negative the entire time. And not applicable. The other way of expressing this exact same answer is A, B, C, C. All right, the other way of expressing it, let's go ahead and make that darker color. The black's not gonna work there. Separating the quantities is to shade it. So I know that it is positive the entire time, so I would just shade that whole region there. Displacement is 0 at A and C. Oop, I lost some lines there.